Besides standard form, another way to represent a quadratic function is by using vertex form, which is f of x equals a times x minus h squared plus k, where a is not equal to 0. So what's cool about vertex form is that instead of having to find the vertex by using math, like with standard form, where we would do x equals negative b over 2a to find the x value and plug it back in to find the y value, with vertex form, you can just look at the equation and be able to tell what the vertex is. So the vertex of a parabola in vertex form is at h comma k. The vertex form also is going to tell us about the min or max value. So just like with standard form, the a value tells us whether or not our parabola opens up or down. So if a is positive, we have a smiley face, so it opens up, and we have a minimum. That means that we'll have a minimum at the k value, which is the y value of the vertex. If a is less than 0, so if a is negative, we have a frowny face, which means that our vertex will be a maximum, and we have a maximum value at the k value, which is the y value of the vertex. The axis of symmetry would be x equals h, because that is the x value of the vertex. So if we look at this example, we want to find the vertex, the axis of symmetry, and the max or min value. So the first thing we're going to do is compare this to our y equals a times x minus h squared plus k. And we're comparing it to vertex form. So from here, we can see that our a value is 3, and our h value is 4, and our k value is negative 2. So having this information, we can find the vertex. So we know that the vertex is going to be at h comma k. So our vertex is going to be at 4, negative 2. The axis of symmetry is going to be x equals the x value of the vertex, which is 4. And then since a is a positive 3, we know that this will be a happy face. So that means that we're going to have a minimum value, and it's going to be a minimum at the y value of the vertex, which is negative 2. So how does the graph of f of x equals x squared move based on the vertex form? So x squared is called our parent function. It's the most basic form of a quadratic function. That means that there's no movement. So there's nothing being added or subtracted or multiplied or divided. It's just the basic function that we have. Once we start to do different operations, we turn it into vertex form, and that's going to translate and rotate and flip and move our graph in different directions. So when we look at vertex form, the a value, and there's a couple of things that the a value can do. So first, the a value can be negative. If it's negative, it means that it's reflected over the x-axis. If it's positive, it's not. Then the a value can be greater than 1. Okay, so if a is greater than 1, if the number is greater than 1, that means that this is going to be a vertical stretch. So the graph itself is going to be stretched up, meaning that it's going to appear skinnier since every point is going to be pulled. If the a value is between 0 and 1, meaning that it's some fraction or decimal between 0 and 1, this means that it's going to be a vertical compression. And what a compression is basically kind of smushing your graph. So if you pushed your graph down, it would get wider. So it appears to be wider. So when a is greater than 1, it's stretched, meaning that it's skinnier looking. When a is between 0 and 1, it's a compression, meaning that it's going to appear wider. Then we have the h in the x minus h squared section, and that is going to determine where it moves, left or right. So if the h value, if you have a negative h there, that means that it's going to move to the right that many spaces. So it's kind of like the opposite of what you think. So if you have a plus there with the h, that means it's going to really move to the left that many spaces. And then the k, that's going to do exactly what you think it does, so that moves it up and down. So if it's positive, it's going to go up. If it's negative, it's going to move down that many spaces. Okay, so the a value The number itself is telling us if it's stretched or compressed. If it's a negative, it's reflected over the x-axis. The h, if it's a minus, it's going to move to the right. If it's a plus, it's going to move to the left. The k, if it's a plus, it's going to move up. And if it's a minus, it's going to move down. All right, so if we think about this graph, if I graph f of x equals x squared, we know that this graph looks like the basic parabola with the vertex at 0, 0. Right? If I plug 1 in and I square it, I get 1. If I plug 2 in, I get 4. If I plug 3 in, I get 9. If I plug negative 1 in, I get 1. If I plug in negative 2, I get 4. If I plug in negative 3, I get 9. So we know that here's our basic parabola. So if I wanted to graph something like, let's say, g of x equals x minus 1 squared plus 3. Okay, I know from being in vertex form that the vertex of this is at 1, 3. So I can go to 1, 3, and I can make my new vertex. Each point is really moving over 1 to the right and 3 up. So even the vertex of 0, 0, if I move that 0, 0 point 1 right and 3 up, I'm going to end up at 1, 3, which is my new vertex. So each point I'm going to move. So at 1, 1, I'm going to move it to the right 1 and 3 up. Negative 1, I'm going to move to the right 1 and 3 up. And then 2, 4, I'm going to move to the right 1 and 3 up. And negative 2, I'm going to move to the right 1 and 3 up. Okay, so this graph is going to be the same shape. It's going to be the same width because I'm not having any type of stretch or compression. There's no negative in front, so it's not reflected. I'm just taking the exact shape of the green graph, and I'm shifting the entire graph to the right 1 and up 3. So what steps transform the graph of f of x equals x squared to f of x equals negative 1/3 x plus 1 squared plus 3? So what we're doing here is just writing in words what's happening. So the negative means that it's going to be reflected over the x-axis. Okay. The 1/3 means that it's going to be compressed. It's vertically compressed by a factor of 1/3. Okay, because it's a number that's between 0 and 1. The x plus 1 squared, so this plus 1, I'm going to bring it over here. So the blue one, the plus 1, because it's plus, it's the opposite of what we think. So it's really going to move to the left 1 unit. And then lastly, this plus 3 at the end, I'm going to bring it over here. That plus 3, because it's on the outside, it's going to move it up because it's exactly what we think because it's plus. So this is going to move up 3 units. So each point of f of x equals x squared would be reflected over the x-axis, would be compressed by a factor of 1/3, would move left 1 unit, and would move up 3 units. Okay, so then we want to write the equation in vertex form for the parabola that is translated 8 units to the right, 1 unit down, vertically stretched by a factor of 2, and then we want to write it in standard form. So we're starting with this function, f of x, and we can start it as kind of like a little skeleton here, because we know that we have to have an x in the parentheses, and it has to be squared, but what's in front of the parenthesis we don't know, what's inside with the x we don't know, and what's outside we don't know. So we kind of write this little skeleton. Then it's saying that it is translated 8 units to the right. So if it's moving to the right or the left, that's going to be inside the parentheses with the x. And remember that that's the opposite sign. So if it's 8 to the right, that means that we're going to have minus 8 on the inside. It's 1 unit down, so we're going to have minus 1 on the outside. And it's vertically stretched by a factor of 2. So 2 is going to go in the front. So this is my vertex form. And then we want to find it in standard form. So when we're converting this to standard form, we want to make sure we follow the order of operations. So we want to make sure that we square that first. So x minus 8 times x minus 8, we're going to FOIL it to get x squared minus 16x plus 64. Then we multiply it by 2. So we're going to distribute the 2 to get 2x squared minus 32x plus 128. And then we'll subtract 1. So our new function, I'm just going to write it as g of x, is going to be 2x squared minus 32x plus 127. Converting standard form to vertex form. So once you have vertex form, you can, like we just did, FOIL it and stuff and get distributed everything and get it to standard form. But when we're starting with standard form and we want to convert it to vertex form, we need to use completing the square. So unlike before, where we moved the 3 to the other side, there's no other side of the equation. Even though there's an equal sign, there's no number on the other side. So we can't subtract 3 to the other side. So what we're going to do is we're going to have the a term and the b term together. And then instead of moving the 3 to the other side, we're going to scoot it down. So we're just going to leave a space and put the plus 3. Okay, from here, what we're going to do is complete the square. The a value is 1, so we don't have to pull anything out. We're going to take the 2, divide by 2, get 1. We're going to square it, so we get 1. And we're going to add 1 back here. Now, when we were solving, we added 1 to both sides of the equation to balance it. But because there's no other side of this, everything's on the same side, in order to balance it, we have to do the opposite. So since we added 1, we're going to subtract 1. We want to make sure that we didn't change any problem and that it's still balanced. So now, I'm going to write this as x minus 1. So remember that minus 1 comes from the number we got when we divided by 2, squared. And then we have plus 2 on the outside. Okay, so we're going to try the same thing. So we have f of x equals. We're going to take the a and the b. We're going to leave a space. And we're going to scoot down the c term. Again, a is 1, so we don't have to take anything out. We're going to take 4 and divide it by 2 to get 2. We're going to square it to get 4. We're going to add it back. And because we added it, we're going to subtract it. So our function ends up being x plus 2 squared minus 10. And it wants us to find the vertex, which is -2, -10. The axis of symmetry, which is x equals -2. And then because the a value is positive, that means that it opens up, and we have a minimum at -10. Okay, now here, we again do the same process. We take the 2x squared and the 12x, and we separate it from the 13. But now the a value is not 1. So we have to take that a value out of the a term and the b term. So we're going to factor out the 2, make it x squared plus 6x. And we're not taking it out of the 13 because that's outside the parenthesis. So now we can complete the square on the 6. So 6 divided by 2 gives me 3. We square it, we get 9. So now, instead of subtracting 9, we're actually going to be subtracting 18 because the 9 times 2 gives us 18. The 2 that we took out, if we distribute it back in, that's going to give us 2x squared minus 12x plus 18. So we physically wrote a 9, but that really represents an 18. So to balance it, we have to have a minus 18. So our final answer would be 2x plus 3 squared minus 5. Okay, and in this last one, same idea, we're going to take out the negative from the first 2 only. So we write it like this, then we take out the negative, so we have x squared plus 2x plus 3 at the end. We take our 2, we divide by 2, we get 1. We square it, we get 1. We add it back. But because of that negative on the outside, it really represents a -1. So to balance it, we have to add a +1. So that's -1 times 1. So we end up with negative x plus